Proxima B orbits Proxima Centauri, a red dwarf star infamous for its intense flares of radiation. The nature of these lights is not yet clear. Are they a signal from an extraterrestrial civilization, or are they simply an unexplained natural phenomenon? Proxima B is far from an ordinary exoplanet. Due to its proximity to Proxima Centauri, it is subject to gravitational locking. This means that one side of the planet is perpetually exposed to the star's light and heat, while the other side remains in constant darkness. This unique orbital arrangement creates a bizarre and extreme planetary condition where one hemisphere is scorched by relentless radiation, and the other is plunged into icy blackness. However, at the delicate boundary between these two extremes lies what scientists call the terminator line. This narrow, shifting band may represent the most Earth-like region on the planet, if such a region can exist under such conditions. Here, the temperatures might be moderate enough to allow for the presence of liquid water and, more importantly, the development or survival of life. This possibility becomes even more compelling if Proxima B has an atmosphere capable of redistributing heat from the perpetually sunlit side to the dark hemisphere, smoothing out temperature differences and creating a more habitable climate in the twilight zone. Preliminary data from the James Webb Space Telescope hint at the possible presence of water vapor, methane, and even oxygen in Proxima B's atmosphere. Though these findings are still awaiting confirmation through peer-reviewed analysis and follow-up observations, they have sparked excitement across the global scientific community. If validated, the presence of these chemicals, especially in combination, could point to biological processes. Of course, such signals could also arise from geological or atmospheric phenomena unrelated to life, but the tantalizing possibility remains. Something may be happening on Proxima B that we've never encountered elsewhere. Perhaps the most intriguing aspect of this discovery is the detection of unusual lights on the surface of Proxima B. These lights exhibit a consistent, non-random pattern that has defied conventional scientific explanations so far. The patterns are not sporadic, nor do they appear to be simple reflections or meteorological effects. Instead, they repeat in an organized fashion, sparking widespread speculation in both the scientific community and the public sphere. While some researchers argue that they may be the result of unfamiliar natural processes, such as exotic chemical reactions or persistent volcanic activity, others propose a far more extraordinary explanation. The lights may be artificial, akin to city lights seen from space on Earth. If this hypothesis proves accurate, it could represent the first direct evidence of an advanced extraterrestrial civilization actively harnessing its star's energy or illuminating its own planetary environment. The implications are staggering. Proxima Centauri, being a red dwarf, emits powerful and frequent solar flares, bursts of radiation that could strip a planet's atmosphere and render it uninhabitable. Despite this hostile environment, some researchers believe life on Proxima B might have adapted to these extreme conditions. Perhaps such life has found refuge underground, shielded beneath the surface, or protected by thick layers of reflective ice capable of absorbing or deflecting radiation. On Earth, life has evolved to survive and even thrive in extreme environments. From the crushing pressures and scalding heat of hydrothermal vents at the bottom of the ocean, to the highly acidic lakes of volcanic regions, to the frozen wastelands of polar ice caps. Given that life on our own planet displays such astonishing resilience and adaptability, it is conceivable that similar traits could evolve elsewhere. Organisms on Proxima B, if they exist, might be biologically engineered by evolution or technology to cope with the stresses of radiation, limited sunlight, and wildly divergent temperature zones. The discovery of these lights marks only the beginning of what could be a transformative era in our understanding of life and the cosmos. Upcoming instruments such as the Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HABEX, are poised to elevate our observational capabilities even further. These tools will allow us to block starlight more effectively and directly observe exoplanets like Proxima B with unprecedented clarity. The potential to detect surface details, atmospheric composition, and possibly even biosignatures or technological artifacts grows more promising with each technological advance. Meanwhile, initiatives like Breakthrough Starshot are pushing the boundaries of interstellar exploration. Engineers and physicists are developing ultra-lightweight, laser-propelled spacecraft, each no larger than a postage stamp, that could travel at 20% the speed of light. At that velocity, such probes could reach Proxima B in just a few decades, sending back real-time images and data from the surface or atmosphere of this enigmatic planet. The scientific and philosophical ramifications of such a mission are profound. We may soon receive our first close-up views of a potentially inhabited exoplanet, an event that would undoubtedly shift our collective understanding of the universe and our place within it. Scientifically, The discovery of lights on Proxima B is groundbreaking. If these signals prove to be artificial in origin, we would possess the first tangible evidence of intelligent life beyond Earth. This would raise profound questions. Who created the lights? How advanced is their technology? How long have they existed on Proxima B? And how have they survived such harsh environmental conditions? What is their culture, their history, their worldview? Do they know about us? Have they seen Earth? The questions seem endless, and each one pulls us deeper into the mystery. Moreover, such a discovery would challenge our long-standing definitions of what makes a planet habitable. For decades, scientists have operated under the assumption that life requires Earth-like atmospheres, liquid water, and mild climates. But if life thrives on Proxima B, where gravitational locking creates extremes of heat and cold, and where radiation poses a constant threat, perhaps adaptability is a more important metric than Earth-likeness. This paradigm shift could open the door to further exploration of similar red dwarf systems. If Proxima B hosts life, what might we find on other nearby exoplanets, such as LHS 1140b or TRAPPIST-1e? The cosmos might be teeming with life in forms we have yet to comprehend. The implications for biology, ethics, theology, and philosophy are immense. Public interest has surged, with social media abuzz with theories ranging from the credible to the fantastical. Academic institutions are engaging in heated debates about the implications of the lights. Some political leaders advocate for caution, urging scientists to thoroughly analyze the data before making any bold declarations. Others see this as a beacon of hope, a possible confirmation that we are not alone in the universe. Efforts to communicate with any potential intelligence on Proxima B are now being reconsidered. Projects like SETI, the Search for Extraterrestrial Intelligence, have been scanning the skies for decades, searching for radio signals or other signs of technologically advanced civilizations. Until now, results have been inconclusive. But the discovery of patterned lights on Proxima B adds a new dimension to the search. Scientists are now contemplating sending targeted signals using powerful radio telescopes, aimed directly at Proxima Centauri and its planetary system. This initiative, however, brings with it a host of ethical concerns. Should we announce our presence to a civilization we know nothing about? What if they are not friendly? What if our signals invite consequences we cannot predict or understand? The so-called dark forest hypothesis, popularized in science fiction, suggests that all civilizations may remain silent for fear of attracting the attention of potentially hostile others. Broadcasting our presence could violate a basic principle of cosmic caution. Ultimately, the lights on Proxima B compel us to rethink our assumptions about where and how life can exist. For decades, astronomers have searched for Earth-like worlds, places with temperate climates, liquid water, and breathable atmospheres. But this discovery suggests that life may arise and flourish in places we've previously deemed uninhabitable. If the lights are artificial, we could be observing a civilization that has overcome immense challenges, survived environmental catastrophes, and harnessed advanced technologies. This possibility expands the boundaries of biology, technology, and planetary science, pushing us to ask new questions and reconsider our place in the universe. This moment is just the beginning. As tools like the Extremely Large Telescope and Breakthrough Starshot come online, we are stepping into a new era of interstellar exploration. Some scientists even envision the possibility of sending human missions to systems like Proxima Centauri in the distant future. While those goals remain decades or even centuries away, interpreting the lights on Proxima B is our immediate challenge. Whether they are a natural occurrence, evidence of extraterrestrial life, or something entirely unexpected, their implications are nothing short of profound. The universe often reveals its secrets in whispers rather than shouts. These lights may be one such whisper, hinting at mysteries far beyond our current understanding. Whether they are natural or technological in origin, they encourage us to look deeper, to question more, and to remain curious. As we continue to gather data, refine our theories, and expand our observational capabilities, one question remains at the heart of it all: are we truly alone? Proxima B urges us to keep searching, to explore the unknown, and to imagine the possibilities that await us among the stars. With every new signal, every strange pattern of light, and every fragment of atmospheric data, we are reminded of how little we truly know, and how much there still is to discover. The cosmos, vast and ancient, may harbor civilizations that have existed long before us or that are only now emerging. What are your thoughts on the lights on Proxima B, natural phenomenon, or something more? As the mystery of the lights on Proxima B deepens, Humanity stands at a precipice between science and something far greater: philosophy, wonder, perhaps even fear. Across the globe, observatories are adjusting their gaze, devoting increasing resources to scanning the Proxima Centauri system. Governments are forming coalitions, secret meetings are held in windowless conference rooms, and top astrophysicists are summoned to brief heads of state. The lights, flickering, rhythmic, persistent, do not align with any known natural pattern. They don't match auroras, wildfires, volcanic emissions, or any magnetic phenomena observed on Earth or modeled in simulations. Their consistency over time suggests not just persistence but intent. At NASA's Jet Propulsion Laboratory, scientists pore over the data, running models, attempting to replicate the spectral